So this corresponds to section 8.2, graph rational functions, and this is from previous night's homework, so it sort of has this shape. First we're going to look at the parent graph. Just like with our radical functions, you have a parent graph, and then you can translate. You can move it up, down, right, left. So the parent graph for rational functions looks like this. Y equals 1 over x. That's kind of like the starting place for all rational functions. So as with any parent graph, if you forget the shape, you make an xy table. So we're going to really carefully just graph the basic one, and then we'll more quickly do the ones from here on. So we make an xy table. Generally you want to choose some negative, 0, and positive values. So I'm gonna just try, I'm gonna kind of illustrate a point here. Negative 2, negative 1, 0, 1, 2. Okay, that should kind of be your default. You say so some negatives, say we have no idea what the shape looks like. So we're gonna start plotting. We're gonna plug these in and plot the points. So in our head, negative 2 in here gives us what? Good, negative 1/2. Negative 1 gives us 0 gives us, this is a very important point here, it's undefined. You cannot divide by 0, so I'm going to write undefined. Can't do it. What does that look like on the graph? What about 1 and 2? Okay, so let's start plotting these points. X and Y axis, and we'll make some tick marks here. Equally spaced. Okay, so let's plot some points. Negative 2, negative 1/2 is about right there. Negative 1, negative 1 is about right there. I can't do anything at 0. 1, 1 is here. 2, 1/2 is there. So do you see from these 4 points that if you don't know ahead of time kind of what something looks like, it can be very difficult to draw a graph. So that's why we're learning what the shape is, so that you always know. So what happens at 0? What you do is you put something called an asymptote. Since x can never be 0, you're going to put a dotted line where x is 0. And it can't touch that. Okay, and as it turns out, since this part can't be 0, y can also never be 0. Because tell me 1 over what is going to give you 0? Can that ever happen? Tell me a number. 1 divided by something is 0. What's that number? Can't happen. So you have another asymptote right here on the x-axis, which is y equals 0. So you have 2 places where it's undefined. And now we need to fill in a little bit more here. If I plug in like negative 1/2, this is why you should always try fractions. What if I plug in for x negative 1/2? What do I get? What happens when you do 1 over a number? What's that called? Starts with an R. Reciprocal, yes. So I just, 1 divided by 1/2 is 2. So it's negative 2. So if I go to negative 1/2, I go down 2. Now you can see the shape a little better. And if I plug in positive 1/2, what do I get? What's 1 over 1/2? Take the reciprocal. 2. Good. So if I plug in 1/2, I get 2, which is up here. And now we can graph it. So the shape of the graph, it just goes like this. It curves up, like you saw in your homework, in this quadrant, and then it curves this way. It gets closer and closer to the axes, but it doesn't touch. So the asymptotes are a part of your graph, and that is the shape of the basic rational function y equals 1 over x. So when we state that, so there's basically a vertical asymptote, vertical asymptote at x equals 0, right here, the line x equals 0, vertical asymptote, and there's a horizontal, because this is what you'll need to figure out where they are. You have to figure out where the asymptotes are first. Horizontal asymptote at y equals 0. And then you pick your points around where the asymptotes are. So and the last part of this is to state the domain and range. This is what you'll be doing in your assignment. You'll graph it, tell where the asymptotes are, and domain and range. So the domain, look to the right and the left. What are all the possible values for x? Everywhere except 0. So what we write is, instead of writing all, well, I'm going to write it first. All real numbers, but not 0. So when you say, for a domain, when you say x not equal to 0, that's what you mean. You mean everything but not 0. But you don't have to write out all real numbers x not 0. You just write x not 0. And for the range, y not 0. Right. You mean all real numbers. So I'll put little quotation marks. But you don't write that, but that's what you mean. The range is y not 0. So even though, let me point out, even though the asymptote is the line y equals 0, that's the line of no touching, it means y cannot be 0. Okay, okay, so that is how you graph a rational function. Now all we have to do is be able to move it up, down, right, left, and instead of these two quadrants as the parent graph, it can you tell me how it would end up in these two? Can you just kind of look at that equation? How would the graph end up in these two quadrants instead of quadrant 1 and 3? Yes, if you put a negative in here, then your graph will end up in these two quadrants. So you know ahead of time. You want to know what the shapes are ahead of time. It helps you to graph. So let's look at this one example here of translating it. So let's say we have, actually I'm going to use a new board. So let me move this out of the way. Let's say I have graph and state the domain and range. This is exactly what you're going to do in your assignment. Graph y equals -2. I'm going to try to make, this is the hardest level that you would have to do, over x plus 1 minus 3. Okay, I want to graph that. This whole thing minus 3. Okay, so this is what you should think. So we want to make this easy. Think of the general form is y equals a over x minus h plus k. So that will tell you, if you compare these, that will tell you what's going on. Since a is negative, you know in general that it's going to be in the second and fourth quadrant, so it'll look, the shape is going to be like this. You kind of know ahead of time that you're going to have, so on all, let me redraw that. So on all these, you're going to figure out where the vertical and horizontal asymptotes are, and then you fill in the shape. If a is positive, it's here and here, and if it's negative, it's going to be there and there. And so that helps you pick the right points. So since a is negative, it's going to be that situation. And now, what can x not be? Well, let's figure out where the asymptotes are before we graph it. Just look by looking at this. What can x not be? Look at this example. What would make it blow up? Yes. So there you go. There's your asymptote. X cannot equal -1, and in fact, that's the domain. So x cannot be -1. That's actually your domain. And so what can y not be? Well, since this whole thing right here can't be 0, this whole part right here can't be 0, what can y not be? -3. That's right. It's going to be this number. So what happens is it shifts to the left 1, since h is -1, shifts left 1, and since k is -3, it's down 3. So you're going to take the parent graph and you're going to move it to the left 1 and down 3. So let's start graphing these asymptotes. So first we know that x can't be -1, so we put a dotted, this is how you graph your asymptotes first. X can't be -1, so put a dotted line there. The dotted line is a part of your graph. And y cannot be -3, so go down to -3 and put at -3, put a asymptote there. So which two quadrants? Is it these two or these two? Yeah, it's going to be these two because a is negative. So we're just going to carefully pick the points that fit around this. So for our XY table, we'll just do 2 on either side. Okay, so we want to pick the right values for x and simply plug them in. So watch this. So x can't be -1, right? So we're not even going to put that in our table. So here's what you do. You pick the 2 to the left of it and the 2 to the right of it. And that'll be enough because we know the shape. So that'll be enough. So x is -2 and -3. So I'll just go in order. It can't be -1. And what are the other two? To the right of it? 0 and 1. So picking those values and plugging them in and plotting those points should be enough for you to be able to graph it. So if we plug -3 in, you can use your calculator if you want, you're just plugging it in here. -3 plus 1 is -2, -2 over -2 is 1, minus 3, -2. -2 plus 1, -1, that's 2, minus 3, -1. 0 is fine to plug in. You get -5, and 1 is fine, you get -4. Is everyone okay with, I'm just plugging those in? You evaluate this first, then you do -2 divided by that, and then subtract 3. You can do it on your calculator. So let's just plot those and graph it, and we'll be done with the hardest example that we can find. So -3, -2, -3, -2 is right there. -2, -1 is right there. Okay, we have those 2 points. So we just make the shape since we know the shape. But that's done. And we had those 2 points. That's good enough. 2 points on each part is good enough. 0, -5 is right here. And 1, -1, 2, 3, 4 is right there. And you know they can't touch the asymptote, so you just get closer and closer. And there's the graph, and sure enough, it's shifted to the left 1 and down 3. It's like, you know that you play a video game and you have a crosshair, right? Like this X, and this X just shifted left 1 and down 3. So the whole thing just moved to the left and down. And then there's our graph of that rational function.